Rate limiting. You've probably heard the term, maybe even implemented it once. But do you really understand why it's one of the most critical pieces of your backend architecture? I'm talking about the mechanism that stands between your application and complete system failure. Today, we're breaking down API rate limiting, what it is, why it matters, and how to implement it properly. Section 1. The problem. Let's start with the problem. Imagine you've built an amazing API, users love it. Then one day a single user accidentally creates an infinite loop in their code. Suddenly they're hitting your endpoint 10,000 times per second. Without rate limiting, your server resources get consumed entirely by this one user. Your database connections max out. Legitimate users start seeing timeouts. Your application crashes. This isn't a hypothetical. This happens to production systems every single day. But it's not just about accidents. Malicious actors use automated tools to scrape data, test stolen credentials, or launch denial-of-service attacks. Rate limiting is your first line of defense. It ensures that no single user or IP address can monopolize your resources. Section 2. How it works. So how does rate limiting actually work? At its core, it's simple. You set a maximum number of requests allowed within a time window. The most common algorithm is called token bucket. Think of it like this. Every user has a bucket that holds tokens. Each API request costs one token. The bucket refills at a steady rate, say 100 tokens per minute. If a user runs out of tokens, their requests get rejected with a 429 status code until tokens refill. Another popular approach is the sliding window algorithm. Instead of fixed time blocks, it tracks requests over a rolling time period. This prevents burst traffic at window boundaries. For example, with a sliding 60-second window, if you've made 100 requests in the last minute, you're blocked, regardless of when those requests happen. Section 3. Implementation strategies. Let's talk implementation. If you're using express.js, the express-rate-limit middleware is your best friend. Install it, configure your limits, and you're protected in minutes. For FastAPI developers, SlowAPI gives you decorator-based rate limiting with minimal code. And if you're working with Supabase, you can implement rate limiting at the database level using PostgreSQL functions and triggers, or use edge functions with middleware. But here's what most developers miss. You need different limits for different endpoints. Your login endpoint might allow 5 attempts per minute. Your search endpoint, maybe 30 requests per minute. Your data export endpoint, perhaps just 1 request per hour. Tailor your limits to the sensitivity and resource cost of each operation. Also, consider who you're rate limiting. IP-based limiting works for public endpoints, but authenticated endpoints should limit by user, ID, or API key. This prevents one user's script from affecting others behind the same corporate proxy or NAT. Section 4. Production tips. Here are some production-ready tips. First, always return clear error messages with your 429 responses. Tell users when they can retry, include a retry after header. Second, log rate limit hits. These logs reveal abuse patterns and help you tune your limits. Third, implement graceful degradation. Instead of hard blocking, you could throttle responses or queue requests. And don't forget monitoring. Track your rate limit hit rates. If 30% of requests are getting blocked, your limits might be too aggressive. If you're never hitting limits, they might be too lenient or you're not under any real load yet. Outrow. Rate limiting isn't glamorous, but it's essential. It protects your infrastructure, ensures fair resource distribution, and keeps your application stable under pressure. Implement it early, tune it carefully, and monitor it constantly. Your future self and your users will thank you.